Hello and welcome to section 2.8 Quadratic Models, and in this section we are going to be using our graphing calculator to do regressions on quadratic functions a little bit more than linear functions. We've done linear functions in the previous chapter in Unit 1, and so now in Unit 2 we are going to do a little quadratic regression. It's similar idea, similar ways of getting these things, and then from there we'll answer a few questions. The one thing that you need to remember, that if you have any questions on any of these, please mark them down, write a question next to the problem that we're doing, so that when we come to class you can be like, you can ask me a question on this, or ask your teacher a question on this. So a study was done to compare the speed in miles per hour with the mileage of an automobile. So here's the table. We're going to enter this table into our graphing calculator to create a scatter plot. Now I've already pre-entered the data into my calculator, but I'm going to remind you how to get there just in case you don't remember. So I'm going to go to Stat, and then under Edit I edit, and then I enter all my data, and let me move over. L1, I just put in the speed X, and the mileage I put in Y. And so then if I want this data to show up, I will go to my graph, but you'll notice that my graph is in the standard window, so nothing is showing up, and you can see my X values are 15, 20, all the way up to 70, so the data is somewhere out on the side where we can't see it. So you might want to enter this data in your calculator. Pause this, enter the data in your calculator under Stat and Edit, so that you can follow along with what we're doing. So since this doesn't show up, what I would do is go second y equals, and I'm going to turn my stat plot on, and you'll notice it's already on. So I just have to make sure that I'm using list 1 and list 2. And if you can't get list 1 and list 2, then change it in your edit part. Change it to the list that you're using, and they're just down here. You just do a second and change it to the list number that you're going to use, and I'll talk more about that in the next one. And if you have problems with that, please come talk to us. Talk to your teacher, and their teacher can help fix this for you. But I'm at my graph. I've already entered all my data for this one, and so now I'm going to go ahead and find the data. And so one of the things you can do is do a zoom, and I'm going to do a zoom stat, which is down here at number 9. And so there's the information, and you can kind of see it looks something like this. So we're using our graphing calculator, so we have plotted the data. That's step 1. So I'm going to pull this graph, put it like right here. And so this is the plot of the data that we're looking at, and so then it says use the regression feature to find the model that best fits this. Which model would you choose? Now looking at this, does this look like a line? Am I going to use linear regression? Probably not, because the thing curves back down. It kind of looks like a parabola, so I'm going to use a quadratic regression. And to get that, we go to Stat again, and this time, remember, just like linear regression, we go over to Calculate, and we'll arrow down to linear regression is what we're used to using, but we're going to do quadratic regression because it looks like a quadratic function. A cubic function, remember, is kind of the S-shaped graph. A quartic is W-shaped. This one looks a lot like a quadratic, so I'm going to use quadratic regression on this one, which is number 5. And so, oops, let me clear this out, sorry. We'll do it again. We've got, go over to Calculate, go down to Quadratic Regression, which is number 5. Now I've got Quadratic Regression, and instead of me typing in all the values that I'm going to get, because it's going to give me an A, a B, and a C like we would use for our quadratic formula, we're actually going to I'm actually going to have this plug it into the y value for me, into my y equals, so that the line will be drawn automatically. So if you don't remember, it's under variables right here. So I'm going to hit the vars button, move over to function, y vars and function, hit enter on that, and then there's y1. So I'm telling it, take the quadratic regression and whatever it is, put it in y1. So now when I hit enter, I'll get my function. There is my function. It's really small. It's an upside down quadratic function. It looks something like this. And when I do this, then I have my information for my graph, and I can go ahead, and now that I know this, I can see what my graph looks like, and you can see there's my quadratic function fitting in there. So now I have my function, and you could write out, and let me go back here. Let me go back to my just go back to this screen. So there are my A, B, and C values. I'm going to put those over there. And so I could write my quadratic function, which we probably should do for this, is write it out. And I would say something like y equals negative 0.0082 x squared plus 0.7. I ran out of room. I'm going to have to move down here. 0.746 x plus 13.472. So there's our quadratic function, and that's how this graph appeared in here. And so then if they want to know what the greatest speed is for our at which the mileage is the greatest, so we want to find out, everything is asking for the greatest, the top speed when we can get the best mile per hour. So we're looking for a maximum, because up here at the top of my parabola is going to be the greatest speed that I can go and still get good mile per hour. So that's what I'm going to find. I'm going to use my maximum feature, and so then I go ahead and say this is where I go second trace, which is calculate, and I'm going to calculate a maximum in this case. And so now I just have to go to below the maximum on both sides, what I would think the maximum might be, and then go back and find the maximum. There it is. And so I will remove this one from my calculator so we can talk about it. And basically what we've got here is, this is my function, and they're telling me that if I am going at 40, let's see, if we're going at 40 miles per hour, 45 miles per hour, according to this function, at 45 miles per hour, I'm going to average about 30.4 miles per gallon, basically my mileage that I would get out of this. Though that's going to be my best miles per gallon that I'm going to get for this, and so that's really what we're trying to get, my best mileage when I'm going 45 miles per hour. So the ordered pair down here is basically what we're looking for, and even though so we will continue on with the next example, and in the next example we are talking about how a basketball is dropped from a height of 5.25 feet, and the height of the basketball is recorded 23 times in 0.02 second intervals. The result is in this table, and I'll show you the whole table. It goes down, continues down, so you might want to pause it, to get the whole table. Maybe I can shrink the table a little bit and make it a little bit better to see. I don't know if I can or not. Let's see. It's a little oddly placed, but we'll see. Maybe you can see the whole table at once if I make it a little bit smaller. There you go. So now you can enter this data. The results are shown in the table. Use the graphing utility to find the model that best fits this. Then use the model to predict the time when the basketball will hit the ground. So do this by hand and on the calculator. Okay. So we need to first find the equation when the ball is going to hit the ground, and then we can go ahead and predict when it will actually hit the ground via the calculator. So if you are looking at your graphing calculator, I am going to clear out the old information. I'm going to turn off the first plot so that my data is gone. If I go to my graph, I'm going to reset my graph by going to my window, or I go to my zoom and go zoom standard. So there's my standard window again. I've turned off the data by going up to y equals, and if you just arrow up to plot 1, which should be dark, you hit enter on it, and then when you arrow away it will be turned off. You can go ahead and in stat, if we're going to edit, we're going to enter this information. I should move the calculator out of the way. You're going to enter this information under stat edit. You can do it in L1 and L2, but since I was doing these two examples, I entered this basketball one in L3 and L4, so I'm going to turn on a different stat plot. But if you want to clear out your old data from example 1 and enter this data, you should do so, and it'll be basically the same setup as what I'm doing. So as you do this, you can go ahead and pause this and get the data in. I am going to continue on with this. So I've gone to Stat, and I'm under Edit, and if I go over, you can look at my L3 and L4 is all the data that is in there, and if I arrow down, you can see I entered all the data. And the one thing about your graphing calculator, it won't go to this many decimal places. If you notice, 4 decimal places as far as the graph will go, so you're just going to kind of have to round or just truncate, mean drop off the last few decimal places after the 4 to get this thing to be able to enter it in your graphing calculator. So when you look at my data that I put in here, it's going to be a little bit different than the data out here just because I can only go to 4 decimal places. So now what I'm going to do with this, once I've got the data entered, I'm going to use my calculator to find the model of this. And to do this, I remember I'm under Stat, and I'm going to calculate, well actually first I should see if I can look at it on the graph so I know what kind of model I'm going to get here. And so what I need to do is, well, if I go to my y equal, or my second y equals, I put my L3 and L4, which is what I'm using, where I entered my data, so I put that in plot 2, so I'm going to turn on plot 2. But if you entered your data in L1 and L2, then you just make sure plot 1 is still on, and it'll show up. So I'm going to hit graph, and you can see none of the data is there. So remember, you go to zoom, and I'm going to go to zoom stat, which was 9, I believe. So I'm going to go to zoom stat 9, hit enter, and well, let's hold on a second here. Oh, my plot 2, I never turned it on, so let's turn it on. I can turn it on this way too. And oh, there it is, all kind of crunched together. So I'm going to go to zoom stat, which gives me some data that looks like this. And I might want to change my window just a little bit because I would like to see my y-axis, or see my x-axis. So I'm going to make this guy go down to -1, just so the x-axis appears in the graph, because that's kind of nice. And I'm actually going to move my window, my x-max out to, let's go to 0.7. The reason I'm doing that is so I can kind of see what the model looks like, and also I'm going to need to predict when it hits the ground, so I'm looking for when it crosses the x-axis. So this is the graph that I get when I just plot these points, and hopefully you can see that this thing is probably not going to be linear. You got a little curve at the top, and then it kind of goes down. So hopefully you're noticing that it looks like it's an upside down parabola, which means I'm going to use my quadratic regression to get this. So I'm going to go to go to my stat, sorry, and go over to calculate, and I'm going to go down to quadratic regression, which is number 5 there. Hit enter. And that's the old one. So then down here, I'm going to remember put the equation in to my y equals by going to after I got the quadratic regression to show up, I'm going over to vars, moving over to y vars, hit function, and I'm going to put it in y1 again because I cleared it out of the old one. And now when I hit my graph, I didn't hit enter on my screen back there. Let's go back. I got to hit enter so that it shows up. There's my quadratic regression. That's the equation. That looks, wait a second, that looks a lot like the other one. Oh, because it's still using L1 and L2. Okay, so since I didn't get the right one, it's because I'm using L2 or L3 and L4. And if you went back and put this data into L1, you don't have to do this next step. So what I'm going to do is I go to stat and calculate, and I'm still going to do the quadratic regression, and so that shows up. And if you put them in L3, L4, what you need to do is you need to go second L3, comma, you just need to tell it which one to do the linear regression on to get the function. And then I'm going to put a comma and tell it where to put it into y1. And so I'm going to do what I've done before. And so now this should work, that if I hit enter, I'll get my there's my regression for this function, so I'm going to pull this one out. And hopefully, if I go to y1, there it is. Alright, so now when I go to my graph, I have a predictive equation, and so I can pull that part out. And so let's kind of talk about this. I would have a quadratic function that would be something like y equals negative 15.44x squared minus 1.306x and plus 5.234, and maybe that should be a 7 over here, from the data. And so this is the function that we're using to predict when the ball hits the ground. And so in order to do this, if we're going to do this by hand, I'm going to put 0 in for x and solve it, and solve for x by factoring or quadratic formula or something to that effect. And so we can talk more about that in class. What I'm actually going to do is I'm going to use the graphing calculator to predict when this thing will hit the ground, and that's basically what I need is to find out when your y value equals 0, because that's the ball's on the ground, that's the height, and when the y value is 0 is basically my is what we call a 0 or a root or a solution. So what I'm going to do is use this equation, and this time instead of finding a maximum or minimum, I'm going to go ahead and do second calculate and find a 0 when it crosses a solution, when it crosses the x-axis. So I am going to go above the graph, hit enter, go above the x-axis, go below the x-axis, and try to guess about where it's going to be, and you can see that it's going to take about a half a second, a little over half a second for the ball to hit the ground, which we weren't there yet, but that's the solution. Remember, if you have any questions on any of this stuff, please come to class prepared to ask them, and I will see you guys in class.